Good day, viewers. Yeah, welcome back to the second class in our calculation involving chemical formulae. Now, first class, we've looked at how to calculate the relative molecular mass of a compound or molecule. Today, we're going to be looking at how to calculate the percentage composition by mass of each element in the molecule. To calculate the percentage composition by mass, the first thing to calculate is to get our relative molecular mass of the compound, and then the percentage by mass of the elements. Percentage composition, percentage composition of any element will equals to the mass of the elements in the compound divided by relative molecular mass of the compound multiplied by 100%. So this is the formula to adopt in calculating percentage by mass of any element. Before we move on to the example, if you are a new member on this channel, kindly subscribe and click the notification bell for my subsequent lessons. Example 1. Calculate the percentage composition by mass of a calcium oxide and other ones. Given the relative atomic masses of each element in the compounds, the first step is to calculate the relative molecular mass of the compound. Calcium oxide, atomic mass of calcium is 40 plus oxygen 16. This gives 56. So I want to calculate the percentage by mass of each element in this calcium oxide. So the first one is calcium. Percentage by mass of calcium equals to mass of calcium in this calculation, that is 40, divided by relative molecular mass of the compound, which is 56, multiplied by 100. So when we do it, we have 71.4%. Now we are able to calculate for calcium. Let's get for oxygen. Percentage by mass of oxygen will equal to the mass of oxygen here is 16 divided by relative molecular mass of oxygen 56 multiplied by 100. So this gives 28.6%. So this is how to calculate for this. And also, since you've calculated for calcium, which is 71.4%, we can equally take away 71.4 from 100 to give us 28.6 instead of working it again. Now, this is the first one. The second one, tetraozosulfate 6. So we have, first of all, calculate the relative molecular mass of H2SO4. So we have it to be hydrogen, atomic mass of hydrogen is 1 multiplied by 2 plus sulfur. Sulfur is 32 plus oxygen 16 multiplied by 4. So we have 2 plus 32 plus 64. This gives 98. So this is the relative molecular mass of H2SO4. Now let us now calculate the percentage composition of each element here. We have three elements: hydrogen, sulfur, and oxygen. So percentage by mass of hydrogen. So mass of hydrogen in this compound is 2. That is 2 divided by 98 multiplied by 100. This gives 2%. Now, sulfur. Percentage by mass of sulfur. Sulfur in this here calculation is 32 divided by 98 multiplied by 100. So we have 32.7%. So the percentage of oxygen can be calculated by the addition of these 2% and 32.7, and take it away from 100%. That is, percentage of oxygen will give us 100 minus 2 plus 32.7, which is 100 minus 34.7, which gives 65.3%. Now the last one, sodium triosocarbonate 4 decahydrates. So we have the first thing to calculate the relative molecular mass of this. So sodium is 23 multiplied by 2 plus carbon 12 plus oxygen 16 times 3 then plus 10 open bracket hydrogen is 1 times 2 plus 16. So we have 46 plus 12 plus 48 plus 10 bracket 18. So we have 46 plus 12 plus 48 plus 180. So when you sum up everything, we have 286. Now, let us now calculate percentage combination of each element. We have sodium, carbon, oxygen, then we have water. So percentage by mass of sodium. So mass of sodium in this calculation is 46. 46 divided by 286 multiplied by 100. So when you do it, we have 16.1%. The second one is carbon. Percentage by mass of carbon equals to, carbon here is 12. 12 divided by 286 multiplied by 100. Now, so you multiply 12 times 100 divided by 286. What do we have? We have 4.2%. Likewise, oxygen. Percentage of oxygen will equals to mass of oxygen in this calculation, that is 48. 48 divided by 286 times 100. 48 times 100 divided by 286. It gives 16.8%. While the last one is that of water. Percentage of H2O will equals to the mass of H2O, which is 180 divided by 286 multiplied by 100. So what do we have? We have 62.9%. So this is how to calculate the percentage combination of elements in a compound. And don't forget, if we add the each of these percentages together, it's going to give us 100. Example 2. Calculate the percentage by mass of oxygen in glucose. Glucose is C6, H12O6. So that's the first stage is to calculate the relative molecular mass of glucose. Carbon is 12 multiplied by 6 plus hydrogen is 1 multiplied by 12 plus oxygen is 16 multiplied by 6. So we have 12 times 6, we have 72 plus 1 times 12, we have 12 plus 16 times 6, we have 96. When you sum everything up, we have 180 as our relative molecular mass of glucose. Now, the question says we should calculate the percentage by mass of oxygen. Now, percentage by mass of oxygen in this compound, oxygen is 96. 96 divided by 180 multiplied by 100. So what do we have? 53.3%. Example 3. In Mg open bracket HXO3 bracket 2, the percentage of magnesium by mass is 16.4%. Calculate the question A, relative molecular mass of the compound. Question B, relative atomic mass of X. Given the atomic mass of each element. Now, firstly, from the question, we have this is a compound, and we have the percentage of magnesium. And don't forget, percentage of magnesium equals to mass of magnesium, according to the formula, over relative molecular mass multiplied by 100%. And the mass of, want to calculate the relative molecular mass of the compound, which is this Mr. Now, percentage of magnesium, that is question A, is given as 16.4%, is equals to mass of magnesium. Magnesium is just Mg, and Mg is 24. 24 divided by Mr. Now, if I'm to put this 100 here, this percentage will not be here. But now I'm putting this percentage here, I won't put the 100 here again. This will now be 16.4 divided by 100 is equals to 24 divided by mr, cross multiply. I'm going to have 16.4 mr is equals to 100 multiplied by 24. So you divide both sides by 16.4. So we have 16.4 mr divided by 16.4 is equals to 100 multiplied by 24 divided by 16.4. This cancel this. My mr equals to, so 100 multiplied by 24 divided by 16.4, 146. So the relative molecular mass of the compound is 146. The next question is to find the relative atomic mass of X. So we've known our relative molecular mass of the compound now. Now, we want to calculate the relative molecular mass, atomic mass of X. And now we are able to calculate the relative molecular mass of this compound with 146. So since this one equals to this, atomic mass of magnesium is 24 plus hydrogen is 1 plus X plus oxygen is 16 multiplied by 3 bracket 2 is equals to 146. So we have 24 plus 1 plus X plus 16 times 3, 48 bracket 2 equals to 146. 24 plus 48 plus 1, we have 49. 49 plus S bracket 2 equals 146. So we open the brackets. 24 plus 2 multiplied by 49, we have 8. We have 98 plus 2 times X, 2x equals 146. So we have 24 plus 98, that is 2. 2x, 122 plus 2x is equals to 146. So let's take this here. So we have 2x is equals to 146. When this plus crosses changes to what? Minus 122. So 2x is equals to 24. So divide both sides by these 2. X equals to 24 over 2 is equals to 12. So the value of X in this compound is equals to 12. So this is how to calculate the percentage composition by mass of each element in a compound. Do not forget to subscribe if you are a new member on this channel and click the notification bell for my subsequent lesson. Likewise, do try to share to other learners in order to benefit immensely on this channel. Thank you very much.